And now we'll give the word to Raphaël to talk about the DevOps Stack, the framework, how to deploy a standardized Kubernetes platform and its ecosystem using a GitOps approach. Raphaël, up to you.
Thank you very much, Thierry. So there's so many ways, so many transitions that would be possible from the previous talk. I was just listening to Pierre-Yves making references to Puppet, to the way they got to containers, all the ways that things were deployed in the demo to show SKS. And because this is a bit special, because Exoscale just released and announced SKS and just demoted, I decided that I would use SKS as an example to show the DevOps Stack. So some of you might have attended a talk I gave in September last year, September 2020. That was a talk about Argo CD. And there are some similarities. In fact, what I presented in the talk about Argo CD last year is what gave birth to the product that we now call the DevOps Stack at Camptocamp. So I actually shamelessly reused some of the slides in the beginning of this talk. So for those who don't know me, my name is Raphaël Pinson. I work at Camptocamp. I've been working there for the last 9 years. I'm an infrastructure developer, passionate about DevOps, DevOps culture, DevOps practices, and all the tooling that goes around it. Pierre-Yves before mentioned Puppet and mentioned Debian packaging. This has been some of my activities in the last few years. And recently, I've been more into containers, Terraform, Kubernetes. Generally speaking, what I try to do and what we try to do in our team at Camptocamp is automate things and automate things in a declarative way. And this is extremely important for us to ensure permanent automation, to ensure something that, for a lot of people will look like the DevOps loop. I'll get back to this in a short while. So we work with a lot of different tools to ensure this. Historically, we've worked a lot with Puppet. We've worked a bit with Ansible as well, and we're Red Hat partners. So obviously Ansible is a tool we use as well. Lots of Linux OSs, Terraform to automate cloud provisioning, all kinds of observability tools. And when it comes to containers, we've historically worked with Rancher first, starting in 2016. Rancher 1 with Cattle, and then more recently in the last 3-4 years, especially with Kubernetes and in particular OpenShift, and integrating this with our existing infrastructures. So what Pierre-Yves was sharing about the challenges of switching to containers and to container-centric infrastructure is really something that obviously speaks to me. I added a little Argo CD here, and I noted that Pierre-Yves actually mentioned Argo CD, and this will be central to this talk. So yeah, we care about deployment. We care about having a continuous deployment. This is also a link with the first talk about Jenkins and about continuous deployment and continuous integration, continuous deployment. For us, this is something that is linked to having all that we can put into Git, whether it's the code to manage the infrastructure itself, the machines using Puppet, the provisioning of the infrastructure using Terraform. But then once we start Kubernetes clusters, we have the same issue. And you've seen in the demo of SKS how you can end up just typing commands using kube control, applying YAML manifest manually. And we want to avoid this. We want to automate things as much as possible and get into this constant loop of automation and of declarative automation so that things get applied in an idempotent way regularly and continuously. So there's lots of tools that ended up getting included into Kubernetes. We saw Jenkins before, it's actually mentioned here. There's lots of things that are at the base, like for example, at Exoscale, they use Cloud Stack to automate the machines. This is one of the tools that could be listed here with OpenStack. All the automation tools we've used for years, and we try to include everything into Kubernetes and manage all this thing in the same automated way we've been wanting and trying to do for the last 15 to 20 years. There's actually many more than this. I just listed a few of them. You just need to look at the landscape page on cncf.io to have a sheer idea of all the tooling there is, and that's not even a full list of what there is. So we tend to deploy things on Kubernetes, and when you get a Kubernetes at first, you tend to deploy things manually. You take your YAML files, deploy them with kubectl apply, maybe use some Helm files, Helm charts, and deploy them using Helm. And it's still an imperative way of doing things. It's still more or less manual. Argo CD can help, and Argo CD should help. And so Helm is not enough, and we've switched for the last year and a half, 2 years roughly, to Argo CD in most of our projects. And this leads, I've talked about this 6 months ago, so I'm going to go a bit quickly on this. This leads to a problem of chicken and egg, or as we have it here, octopus and egg, in the case of Argo CD, which comes first, because if Argo CD can automate everything on a Kubernetes cluster, well, Argo CD is an application that is deployed on Kubernetes in itself, so does it manage itself? And so very often you'll start by installing Argo CD and making Argo CD manage itself. So fine, we've deployed Argo CD, we've got applications we can deploy with Argo CD, and we're happy with this. This is what I presented in last September. But we still had a problem. We still had a problem of how to automate all the things in different projects without duplicating code. So this is what gave birth to the project we now call the DevOps Stack, whether it's a good choice of name, I'll let you choose. And it aims to help you deploy in a what is now called GitOps way, so declarative, continuous delivery, continuous deployment manner, a Kubernetes cluster and all the applications on top of it. And that includes what was mentioned in the previous talk, ingress controllers, certificate management, monitoring, all this stuff. So before we had this DevOps stack, this is what we had actually. We would use Argo CD, we would use all kinds of automation, so typically using Terraform to provision the cluster, whether it's EKS, AKS, SKS now with Exoscale. We try to automate this using pipelines as much as possible. So here we've been using GitLab CI, for example, but it could be done with Jenkins as well. And then we had a Kubernetes cluster on top of it that was installed by Terraform, and we would apply Helm charts on top of it to configure the ingress controllers, to configure the certificate management, to configure monitoring, to configure Argo CD itself, all these kinds of things. But because it's very complex, we ended up copying and pasting tons of things, backporting patches from one project to another, pointing to Terraform modules in different versions, to Terraform providers in different versions, to Helm charts in different versions. Sometimes it's not even Helm charts, it's customized that is used in some repositories. So it was generally a big mess and no standard in automation and in what you could expect from a cluster. If you installed an AKS cluster in one corner and an EKS cluster and an SKS cluster somewhere else, you could end up with very different environments. So we wanted standardization, we wanted automation, and we wanted a declarative way of automating things using pipelines to automate a declarative deployment process with Terraform, and using Argo CD to deploy all the applications in a continuous deployment manner on Kubernetes. So this is what we have now. The DevOps Stack comes as a middleware, as an interface between the projects and the things we need to instantiate to get this project going. So here, a project will use Terraform still to instantiate the Kubernetes cluster, whether it's on EKS, AKS, SKS, you name it, except it will use a Terraform module or a set of Terraform modules that have been made to be standard within what we call the DevOps Stack. It will use pipelines again, but instead of having different pipelines for different projects, we have standard pipelines that are provided in the DevOps Stack, and these pipelines allow to properly make Terraform diffs, so plans, apply, make diffs in the merge requests so that we can see what is going to change on the Kubernetes cluster before we merge it. So we have the same pipelines in every project managed through this DevOps stack. And then finally, once we have the Kubernetes cluster, we want to manage the instantiation of Argo CD itself, the octopus and egg problem itself, as well as most of the applications we deploy, the standard application, the standard stack we deploy on top of Kubernetes. So typically, everything related to certificate management, which is extremely central if you want a cluster that actually works properly. So let's encrypt using Cert Manager. Everything related to cluster metrics, which is standard in some implementations of Kubernetes, not in others. So we put it as a standard in the DevOps stack. Everything related to monitoring. So we chose a standard implementation of the Prometheus, Grafana, Loki stack and included it. So we have the same monitoring stack on every cluster, whether it's on AKS, SKS, and so on. And then we're adding more and more of this so that we have standard components, just like we did with Puppet pretty much when we manage nodes that are included there. And we can choose where we want to deploy a Kubernetes cluster and have the standard stack on top of the Kubernetes cluster. And so the DevOps stack is the central point that will instantiate the Terraform providers, the Terraform modules, and the Terraform chart and the Helm charts. And the versions are pinned with the DevOps stack version. So if you use the DevOps stack version, a specific DevOps stack version, you have a specific API that comes with it and specific versions of components that comes with it. So what are the types of components we're including in this? Obviously, Kubernetes is very central. It's the installation is entirely automated using Terraform. The deployment of applications on top of Kubernetes is done with Argo CD. And then on top of this, by default, we deploy Prometheus, Grafana, Loki, Cert Manager, Traffic currently as the ingress controller, but we might switch to Contour in the future. And one thing that is very important is authentication to all these web applications. And authentication is not a given. It's a complex thing. The standard for authentication nowadays is OpenID Connect, which is sometimes implemented using OAuth 2 directly. There's lots of OpenID Connect providers. You can use GitLab. You can use services that are provided by the clouds. For example, in Amazon, there's Cognito. In Azure, there's Azure AD. And so what we did is that whenever we provide an abstraction to install a cluster with the DevOps stack, we try to integrate with an OpenID connector. And typically, if you deploy the DevOps stack on Amazon, it will. We have examples of how to integrate it with Cognito so that all of these applications are directly configured to be authenticated using Cognito. If you deploy on Azure, it will be automatically configured to work with Azure AD, and so on and so forth. And if you prefer, you can bring your own OpenID Connect if you want to log in with GitLab or with your own Active Directory, for example. You bring your own OpenID Connect, pass the variables to the DevOps stack, and it will configure all of these applications for authentication properly using this OpenID Connect provider. So obviously that means that because we deploy all these charts that provide all these functionalities, we have really nice graph, we have really nice what we call second-day operation tools that are integrated with Grafana. For example, here, these are standard graphs to manage the cluster and to view the cluster, and you can dig into namespaces and pods and all this stuff. And this is provided directly in Grafana by the Kubernetes stack that is instantiated. There's some dashboards that are provided by default for Cert Manager to see all the certificates that were created by Cert Manager in the cluster and see when they will expire. And there's other dashboards. I haven't included everything here, but typically dashboards for Argo CD, so you can see all the applications that are being managed. And when Argo CD is making changes to the resources to adjust. And we typically deploy Argo CD using an auto sync approach so that it will fix the resources in the cluster dynamically. So that instead of only having a convergent approach to deployment, we actually have a congruent approach to deployment. And Argo CD is working as a tool that constantly fixes things in the cluster if there is divergence, if there is a configuration drift between what we've put in Git and what ends up in the cluster. By the way, the Argo CD we deploy in the cluster to manage our own DevOps Stack applications can be used for your applications, and there's a possibility to pass extra repositories to Argo CD in the Terraform code for the DevOps Stack, so you can deploy your own applications using the same Argo CD that is already configured, already set up with the authentication with the OIDC provider. So it's all ready to be used even for your developers. You just need to provide the link to your Git repository to deploy other applications. So I'm going to take an example, and I'm going to try a demo. I don't guarantee anything, to be honest. This demo has been worked on heavily this week, including today, so I'm hoping it will work. But I'll try it. If it works, it shouldn't be too long. So here's an example. This cube config is empty. Actually, I can remove it. I'll remove the Terraform states here. So here, that is enough. I have this YAML file, the secrets.yaml, with my keys to access the Exoscale API. And then the main.tf is very simple Terraform code that points to the DevOps Stack. I'm currently pointing to a branch by my colleague Michael, who is working on the SKS integration into the DevOps Stack. It's not finalized, but we're getting there. I was hoping to get it finalized for today, but well, almost. So I'm also specifically pointing to the same branch for Argo CD because there are some changes that are necessary in Argo CD to make it work with SKS. And I'm specifically starting the routers with large instances instead of medium because by default we had medium so far. And then I have some outputs here. One output specifically is the kube config that we will get from Terraform. So I'm able to actually log into the cluster. So let me try this. I'm using summon. Summon reads the secrets.yaml file to inject the keys. So I'm not going to show you the secrets.yaml. It doesn't need to be shown. So let's see. So ideally, as I showed before, the idea of the DevOps Stack is to include this into pipelines. So in production, I would not launch this manually. I would include this into pipelines, typically using Jenkins, GitLab CI, GitHub Actions, and so on and so forth, so that whenever I commit this code into Git, it would automatically apply the code using Terraform in a CI instead of using my credentials locally. For the demo, using the credentials locally is actually easier as I control exactly what happens and when it happens. So here, Terraform is actually creating the cluster. How it works is we use Terraform modules to provide an abstraction between the DevOps Stack and the instantiation of the Terraform resources, because this is usually quite complex. If you want to manually create a Kubernetes cluster with SKS manually with Terraform, you'll need to create all kinds of firewall rules, so security groups, nodes, the SKS cluster itself, plug everything together, different node groups, and so on. So we provide this module here called SKS Exoscale on the Terraform registry. And this already provides an abstraction on top of SKS. And then the DevOps Stack bases itself on this abstraction to deploy the cluster. So for each of the different types of Kubernetes clusters we support, we base ourselves on a Terraform module that provides an abstraction. Oops, what am I doing? So the cluster is creating. It usually takes only a few minutes. So I'll let it run and I'll continue with the slides and we'll get back to this. But you can see that it's very simple to create just a simple cluster. Just this few lines should be enough. Even these 2 lines here could be removed. And there's many more attributes, parameters I could pass if I wanted to tune the way the DevOps stack is deployed, and typically the authentication, for example. So here, Exoscale doesn't provide an OIDC provider. So what it will do is it will deploy a key cloak operator, and key cloak will be the OIDC provider internally inside the stack. This is what we do for K3S as well. There would be the possibility of passing an OIDC provider directly to the module so that we don't use key cloak. There was one problem with key cloak on Exoscale, which is that it requires a database, a PostgreSQL database, and because there's no database as a service yet, it will be created as a container, and we had to use a little bit of a hack using a local storage class in Kubernetes, which is one of the changes we had to make it work with SKS, because there's no other way of using PVCs at the moment in SKS. I'll let the Exoscale people comment on this because I'm sure this is an interesting subject as well for the future of SKS. So the class that we support at the moment, Amazon AKS, Azure AKS, K3S, either using Docker or libvirt, and Exoscale is almost there. And we're also working on integrating OpenShift for in different installation ways because we use OpenShift a lot. So let's see. Ooh, there is a problem. I thought that might happen. Let me see. I'll try something else. And I can already take questions because there's, I think, 5 minutes left.
So we have one question from Pascal. Could you please explain the choice of Argo than GitHub Toolkit, Cloak, for example?
Sorry, I did not hear that well. The choice of?
Sorry, I heard the echo. Could you please explain the choice of Argo than GitHub Toolkit, Cloak, for example, or now the new OpenShift GitHub? You're on mute. We can't hear you anymore. You're
mute, Raphaël. There, that's better.
There you go.
Okay, thanks. Wait, I'll call this new SKS so that I don't have this problem. And I'll apply again. We started using Argo already a while ago, so we didn't even ask these questions actually. As far as OpenShift GitOps, I haven't tried it myself. I imagine that it is actually quite linked to OpenShift. And the goal of the DevOps Stack is to be a standard way to install Kubernetes clusters outside of OpenShift. So OpenShift is just one of our needs, just one of our use cases. We want to automate AKS, EKS, SKS, and so on. So we wanted a tooling that would be as neutral as possible to do this.
Thank you. And how do you manage to resist links between DevOps Stack version and API TFL version?
Let me see if I can see the questions here because I have a hard time hearing you. How do we manage the
releases? The links between DevOps Stack version and API TFL version.
At the moment we pin the versions of the different Helm charts in each DevOps Stack version. So one DevOps Stack version comes with a specific list of Helm charts configured in a certain way. You can override this. There's always ways in which you can override the configuration, the versions of the charts, the different things that are passed, providing your own YAML files or your own Terraform parameters, depending on what you want to tune. But generally speaking, we pin the versions of the Helm charts to the DevOps Stack versions.
Okay, thank you. And the last question is, how do I install the DevOps Stack?
So we have a website that we actually launched yesterday, this new website. And on this website, there's some quick starts. There will soon be an SKS Quick Start, hopefully by next week. And so if you look, the easiest way is to use the K3S Quick Start if you just want to try it. This is K3S on Docker. So if you just have Docker on your machine and you just use a very simple piece of Terraform code, so just this is enough, and some outputs so you can get the variables, the kubeconfig, the Argo CD server, and so on, and just run Terraform init, Terraform apply. It will deploy K3S on your machine and the DevOps Stack on top of it, and you will have the links to the different services running on top, and you can already see what it looks like. And then if you want a production-ready cluster, you can go either with AKS or EKS. So AKS here on Azure, EKS here. You just need to have credentials that you can pass at the creation of the stack. This is still a pretty new project for us, so I'm sure there's still some things to do, especially in documentation. So feedback is clearly welcome. I see another question: why Terraform and not Ansible? Because Ansible is a tool to deploy applications and is not exactly the best tool. At least we believe it's not exactly the best tool to automate resources on the cloud. Terraform allows for great collaboration between team members when deploying on the cloud, because you have shared remote states. And so we've been using Terraform for this need for the last, I would say 6 years now, 5-6 years, and it made perfect sense for us to go in this direction. So I wish I could show you exactly. It's still deploying. It should be only a few minutes. I'm sorry I had to destroy and recreate it. If you want, Thierry, you can feel free to end it. And if people want to see the end of the demo, I'll be running it still. In case it.
So we'll remain here. I think there is an echo when I'm speaking to your speaker, Raphaël, I guess. Thank you for the presentation, and thank you everybody for your questions. It's great. I just want to share as well with you, and then Raphaël will take back the lead in the end. So that was a presentation of DevOps Stack. He will take back the lead if everything happens back on track. And so that was to thank you. So next meetup that we will have will be on June 17th, and for the second trimester, and the third trimester in October 7th. Please share with us what you feel, what you prefer, what topics you would like to see. We are happy to share it with you. And as well, if you want the presentation, please send us an email or a message on messages, and then we will answer and sending you all the presentation that you got today. And if the demo from Raphaël is not done yet in a couple of minutes, then we will be able to finish recording on this YouTube channel, and you'll be able to see it the end in a few days. As well, the last not least, or like I was mentioning at the very beginning, Submit Islands. We'll have two different topics, one of virtual on April 29th and one on-site on September 23rd. And so with this, I give it back to Raphaël if if it's done, if it's possible or not. Otherwise,
so Terraform finished
thank
running.
you very much for your time.
Yeah, so Terraform finished running. I have now launched Canines, which I strongly suggest. It's a tool to connect to Kubernetes clusters from the command line. So you can see in the pods here, I have more and more pods that are starting on my SKS cluster. I can see the, if I go to the application type, I can see the Argo CD applications that are starting. So there's the app of apps itself, the Prometheus stack, Kubernetes stack is starting. There's a local pass provisioner, which provides a storage class for our key Cloak database. And so the key Cloak should be starting soon. Yes, that's fine. And I'm seeing the different applications being started by Argo CD automatically. And as they are starting, it will also automatically start the ingresses. So here I see the different addresses. I'm using nip.io to make it easier, but we could also have a proper DNS entry, and that would work as well. So here I'm going to connect here to show you the Argo CD interface, and not working yet. Okay, I'm going to wait a little bit.
And while waiting, there is a last question for the configuration. Why instead of Kubernetes Ansible module?
Why Helm instead of? Well, I think even Red Hat is giving up Kubernetes Ansible modules. To be honest, nobody else uses it. And it's pretty clear that the standard for packaging is Helm charts. You've seen it in the way that CloudBees is deploying CloudBees CI. They have Helm charts. Whether you like Helm as a tool is another question. Helm is far from being perfect, but Helm charts is has definitely already become the standard for packaging Kubernetes applications. So I wouldn't even try to use something else at the moment. Now, we're not using Helm to deploy. We're using Argo CD, which uses Helm only for the templating before applying the YAML manifests, but using something else than YAML manifest at this moment, unless it's customized, for example, I wouldn't think about it. Again, using Ansible also means you're in a push direction system, which is generally bad for ongoing automation, whereas Argo CD is a pull system that will pull Git repositories in a constant motion and apply on a regular basis. So it's a much better approach if you want full automation. So traffic is starting, which is why we couldn't access the ingresses at this point. So once traffic is started, we'll have a reverse proxy to access our different applications. I don't know why it's taking so long to start. Oh, the problem was the API. Canines is stuck. Let's see. Start it again. There we go. There. So now we have something. The certificates are not valid yet. Probably Let's Encrypt still running. Insert manager. And what's the matter here? Okay, there's a problem with the routing. I'm going to pretend this is a demo effect, right? I should have done it with KFS instead, but I wanted it a little bit more daring. Okay, never mind. I'll stop at it. But you see the point. Oh, no. Okay. It got scared. So here you see the Grafana dashboard here. I can actually look at the, let's see if the Cloak is working. I have a Cloak user that was automatically created. And if I look at this Cloak user, there's a password here. So I should be able, if Cloak is ready, which I'm not sure about. Hello. If Cloak is ready, I should be able to log in with this password. There's a few problems with the API again. I don't know if we're using the free version or the SLA version of SKS. See, there's some problems. Canines is not able to connect to the cluster. Yeah, some issues here. Okay, that's all right. I think I'll stop here because Cloak is not running yet. But you get the idea. Everything, the Cloak, the Grafana, the Prometheus, and so on, has been deployed automatically using Argo CD, just with this basic Terraform code. So that's the idea. I'll stop presenting for now.
Thank you, Raphaël.